love the chase and the hunt, and I set the pace when I'm running. I always
Namaste Friends. So today is chapter 8 in NumPy, but I think the total chapter is either 46 or 47. So we are actually coming very close to a half a century, but we still have a long way. But Panda can be done very shortly. If you're actually watching my Panda on the side by side, that can be done shortly. But this is like basically NumPy lesson 8. In NumPy lesson 7, we actually saw about array shape, like what is a one-dimensional, what is a two-dimensional, and how we can actually convert a one-dimension to two-dimensional, vice versa. So when we have a shape, we should also have a reshape, right? So that is exactly what we're going to be seeing in today's lecture. All right. So what is a reshape? A reshaping means reshaping the array. The shape of the array is a number of elements in each dimension. By reshaping, we can actually add or remove dimensions or change number of elements in each dimensions. All right. So how do we actually do it? We want to reshape the one-dimensional array to two-dimensional. So let's actually convert the following one-dimensional array with 12 elements into two-dimensional array. The outermost dimensions will have 4 arrays each with 3 elements. So let's actually take this and let's actually run this. Okay, so we are importing a NumPy as this, and this is a one dimension. It has 12, and then we say reshape 4,3. So that is exactly what we did, and let's actually run this. Now see, when we say 4,3, this has been split into 4 parts, and each with 3. So 1 2 3 4 5 6 7 8 9 10 11 12. So this is what we have done, and this is what the reshaping is. All right. So now when we want to reshape from one dimensional to two dimensional, let's actually take care of this, and each with 2 elements. So let's actually see what this thing is. So again, it's the same. This is a 12. In this case, it is quite easy, right? We say split it as 4, each with 3. But in this case, what is this when it goes to 3 dimensional? 2, 3, 2, and what is this? Let's actually run this and see. Very nice. So what it is actually doing here is basically the 4 which actually the 3 here is here 3. So this 3 is this 2. So it is actually taking as 2. It has been split as 4 here. It has been split as 2 here. So in this case, what it is actually happening is 1 2 3 4 5 6. Okay, so 1 2 3 4 5 6. So we have actually split it by 6 numbers. Okay, and that is exactly what this is. And if you go to the PowerPoint, if you say the outermost dimension will have 2 arrays that contains 3 arrays with 2 elements. So that is exactly, that will contain 3 arrays with 2 elements. So what is that? The 3 arrays 1 2 3 with 2 elements. So that is what it says, 3 arrays with 2 elements. And this is just 4 arrays with 3 elements, 3 arrays with 2 elements and starting with 2. So that is exactly what it is. So can we reshape into any shape? Yes, we can actually reshape into any shape, but we cannot reshape into 3 elements. Okay, so 3 rows, 2 elements, 2-dimensional arrays, as it will require 3 times 3 9 elements. Okay, we can reshape an 8 elements 1-dimensional array into 4 elements 4 times 2. But if you want 3 times 3, you need to have 9. So in this case, we only have this. So 3 times 3 9. So 9 is actually missing. So let's actually see what is actually happening. See, there's a value error because of the shape. Okay, because it is only 8. So if I actually say this 4, 2. So 3, 3, we don't have that 9, and that is exactly what I was actually talking of. Okay, now let's actually see if this returned array is a copy or a view. We actually talked about copy and view, but let's actually see what this guy is here. Okay, if it returns the same thing, it is a view. If it a view is only you can view, but you can't massage the data, and the copy is you can actually massage the data. So here it is A. We are reshaping it with the base. So in this case, what it is actually doing is it's giving the same thing, so which is a view, and that is exactly what I've actually said here. Okay, you are allowed to have unknown dimensions. Okay, so when you actually allowed to have unknown dimensions, that you need not specify an exact number. Okay, it is just like a reshape. Now let's actually take this and let's actually run this, and let's see what is actually coming. you're importing a NumPy. This is a one array. Okay, so 2 times like unknown dimension print new ARR. Okay, so let's actually see what this is actually happening. Exactly as we said, types of 2. Okay, and in this 2. Okay, so 1 2 3 4, and this is exactly what it is actually doing. All right. So pass -1 as a value, and num array will actually, when you have an unknown dimension. All right. So flattening the arrays. A flattening array means converting a multi-dimensional array into one-dimensional. Okay, we can use reshape -1 to do this. Again, when you use a reshape -1, it is converting a multi-dimension to single dimensional, and this is what it is. Okay. So this is a multi-dimensional. This is like 2-dimensional. You're actually reshaping, and you're actually giving this. All right. See, now we actually made it single dimensional. So multi-dimensional, single dimensional is what this is called as flattening the array. All right, very simple, right? Now how do we actually write the syntax? Always, friends, remember, if you want to shape the array one dimensional, it is array dot shape. Okay, where this is this variable dot shape. If you want to reshape, it is like 4 times 3 sets. Okay, or this -1 when you want to flatten the multi-dimensional array. So these are some of the syntaxes for you to understand. Okay, you can actually practice in your own this thing, but I'm not going to run this. All right, I think this is good enough for today. If you have any questions, kindly contact me, and I'll actually try to explain to the best of my abilities. So next time I think it will be NumPy iterator. Okay, so like always, I would like to thank 2 persons. One is you for giving me a golden time. The other is my wife Jai. She following me to follow my passion. So till we see next time, you take care, cheers, and thank you.